This one as integration.
In science, general, we can use all of these rules in science, not physics only. Okay? P, pressure. Okay? Then as Mr. Samuel asked me,
Okay, to put simplest one.
so P as Pascal,
Using the Pascal for atmospheric
pressure. Okay? V,
capital. Don't write it be small.
I think you notice that P also is capital. V capital,
That's volume. Volume is measured by meter cube or liter. In chemistry, you can use decimeter cube.
decimeter cube. N,
That is number of moles.
that's first time to take it. Number of moles, that is the amount
of matter. If you remember, in the first session, we talked about the basic
physical quantities. Okay, we put amount of matter by using the mole.
and we wrote mole, M-O-L-E, and I told you we can abbreviate it by, okay, or cancel this one. Say M-O-L-E. That's abbreviation N, and
okay, we can write it as
M-O-L or M-O-L-E, etc.
then we have
T capital, not T small.
T capital, that is
Temperature. And the temperature here should be measured by Kelvin.
remember
Kelvin equal degree of Celsius 273.15, and I told you this one is not in our graph. So we can write it 273 plus Celsius to find it.
okay. Also we have another scale.
And math we got it before.
Then we have
New letters. That's first time to take this letter.
this one is called R capital. R capital,
That is gas constant.
don't memorize it.
Okay.
In the exam, we
We
should
should give it to you. But
to be easier.
and faster, use your calculator, make shift
7. Shift 7. Then
put number 27. When you click shift 7, that is the constant.
the all constant that we use for all signs. 27
Then it will give you R.
make equal, it will give
You are at 8.314. Okay? Memorize it.
okay. Now let us find
The relationship among all of these now with me. The first scientist talk about the gas pressure or the gas law in general. Boyle.
Boyle said that if we have the balloon,
That is the balloon. Okay.
temperature is constant, number of moles,
Also constant.
temperature is constant, number of moles also constant. What do you think?
If I make pushing here,
Is the volume still the same?
or decreases.
Decreases, right? So pressure is inversely
Proportional with volume.
pressure is inversely.
Proportional with volume.
That means when the pressure increases, volume decreases. Opposite. As we discussed before, we can convert this relation, okay, to be equal and make constant. So at the same, that is P equals constant times 1 over V. We can convert the proportional
Directly or inversely as equal and constant.
So in this case, we can say P times V equals constant. Means at constant temperature, constant number of moles, pressure and volume are inversely proportional. Then we can say P1 V1 equals P2 V2, that is Boyle's law. That's the first one. But I think he knows that the other physical quantities should be constant, to be fair. Okay? Now, the second scientist, his name is Charle. This part, Charle's law, not in physics, but you will take it in physics, okay, in AS. Here, Charles said that at constant pressure, at constant moles, number of moles in this gas does not change. Okay? Now, let us say we have here any container, contain gas, and I make heating. What will happen? It will expand. So in this case, volume and temperature are directly proportional at constant pressure and number of moles. Okay? So in this case, V equals constant times T. And don't forget put T capital, don't write T small. And temperature should be measured by Kelvin. If he gave it to you by Celsius, you should change it to Kelvin. You should change it to Kelvin. Don't forget this one. So in this case, we can say V over T equals constant. Then collect this rule and say that V1 over T1 equals V2 over T2, that is Charle's law. And don't forget, at constant pressure and number of moles. The third one, the Guy-Lussac. He discussed another thing. We have a can, okay? Same number of moles, so the number of moles does not change. And fix it here for volume, so also volume does not change. And we make heating. What do you think here, what will happen? The gas particles will gain more amount of energy, right? But here, the volume does not change. So, the action and the motion and the collision among all of these particles and hitting the wall will increase, right? That's mean pressure will increase also. As the internal energy increase, kinetic energy increase, and we told you before, kinetic energy, okay, let's see what I talked about thermal energy happens, right? So the pressure will increase, means pressure is directly proportional with time. Repeat the same way, yes. Pressure equals constant times time. Put it down. Pressure over time equal constant. So we can say in general here, P1 over T1 equals P2 over T2. Okay, let me go. Someone said that now we got three rules: pressure, volume, and temperature. And he said that pressure times volume, constant. Pressure over temperature, constant. Volume over temperature, constant also. So we can say P